Beneath that's Mount Talbot, and on the left of us here is Student Peak. Now all these steep-sided mountains create this U-shaped valley, so flat, wide valley floor and steep mountains around us, typical of a valley carved out by a glacier, which started way up the head of the valley, far away as we can see. I'm just going to point out this waterfall tumbling down Christina to the right. There's quite a few steps on it. That's temporary, bit of snow up around the tops. Now, so this valley carved out by a glacier started way up as far away as we can see from here. It pushed its way over our heads and carved out this upper Holyford Valley. Got to around where the main divide of the Alps is, took a left bend, carved out the lower Holyford Valley, where we saw the beech forest across the valley floor just after crossing over the main divide. Around the same time, other smaller glaciers formed in surrounding rocks. They carved out other valleys and collided side-on with the main glacier, creating hanging valleys like the one that was feeding Monkey Creek a few moments ago. There's a beautiful hanging valley to the right of us here, between Mount Christina, we're leaving behind Mount Crosscut, that we're just joining on the right. Now lower down in the valley, see those couple of patches of white? That's avalanche debris. That's all the snow that tumbled down from the mountain tops a couple of months ago. It takes months for that avalanche debris to melt away. Now higher up at the back of the valley, see the greenish blue colour of the ice of a glacier. That is the remainder of the original glacier that once filled up and carved out that valley and has retreated right back up to there. And so as I was saying, as we travel along the shores of Lake Wakatipu out of Queenstown today, and information for you folks that joined us back at Tiano, the mountains around us here are created by the uplift of the original ocean floor. So hundreds of millions of years ago, with sand, silt, sediment, pebbles, shells settling at the ocean floor, it was then exposed to huge pressure and temperature by the weight of the ocean on top, squeezing it into the solid rock surrounding us. This rock is being pushed up out of the ocean into the sky by the collision of the Australasian and Pacific plates of the Earth's crust. Now the Australasian plate, it ducks underneath, and the Pacific plate pushed into the air at a rate of about 1 centimetre per year. The South Island of New Zealand is still being pushed up out of the ocean. The mountains surrounding us here, they are some of the fastest growing mountain ranges in the world. Now, evidence of the original ocean floor is on your left side here, on this mountain face. See all the layers in the rock on the mountain side? They were once horizontal, because it is the original ocean floor, but as you can see, they have been buckled up almost vertical by collision of plates of the Earth's crust, and that shows just how much buckling up of the landscape is happening around us here. The layers in the rock on the left, once horizontal, but now almost vertical. But as quickly as the mountains rise, they fall as well through forms of erosion. Wind and rain doesn't carve these mountains too much, mostly solid granite rock, but freeze-thaw action does. That's where water gets in between cracks in the rock. Water, as it freezes, it expands, it blows the rock apart, and the rock tumbles down, reducing the altitude of the mountain. So on the right-hand side, see all the loose rock? That's called a scree slope. That's the rock that tumbled down from the side or summit of Mount Crosscut through freeze-thaw action. Bit of avalanche action there as well. But speaking of avalanche, you can see a little trickle of water coming down into some white avalanche debris to the left of us. Now the bare face of rock to the left is an avalanche path. So imagine an avalanche tumbling down the mountain to the left, across the valley floor and across the road every single winter. Right here, right now, we're in the path of a huge snow avalanche, which is called the Raspberry Patch. Crossed over the highway 3 times the last winter season. So 1/3 of the growth of these mountains is lost to erosion, but geologists reckon if there was no such thing as erosion, the mountains around us here could be 22,000 metres tall at the tallest points, and that's about 70,000 feet, twice the cruising altitude of a commercial jet plane. But erosion keeps them down to between 2,500 and 3,500 metres in altitude, but without erosion they could be 10 times higher. But as we climb up here, we got evidence of erosion. Now on the right hand side, a big rock slide tumbled down during the floods in February of 2020. The next probably 300-400 metres of this highway was completely washed away by the Holyford River. They had to rebuild this entire section here. Now looking left and right of us, boulders, they either tumbled off the mountains and ended up here, or else they're ripped away by glaciers and deposited here. They'll get broken up into pieces by freeze-thaw action and weathering, washed out at the coast by the Holyford River, we're just about to cross over. And for Cantabrians on board, the Canterbury Plains, that's all rock that's been eroded away from the Southern Alps as well, washed out toward the coast. Now we're up on about 800 metres above sea level now, encountering mountain beech trees. The trees around us here are a smaller, a stunted version of the tall straight red and silver we saw in the Eglinton Valley earlier, mountain beech trees. To the right of us, a stunning valley that's called the Gertrude, very popular for adventuring. And about 3 years ago, two of my friends and I, we drove down here and parked my car down